So we'll move on to the next material after discussing regarding the various blocks. We'll move on to the next material that will be used in the construction of a building. So next is lime pozzolana cement. Lime pozzolana cement. See, this is a very best alternative to the conventional cement. This is the best alternative to the conventional cement. We can go ahead or we can use it in the construction of building. So what is the meaning of lime pozzolana cement? It is a cement which will be produced with a mixture of lime and pozzolana. Okay, it is a mixture of lime and pozzolana. By combining these two, we can produce a lime pozzolana cement. So let me go ahead one by one. So first we will discuss regarding the lime, and later on I will move with respect to the pozzolana. So first, the raw material required for LPC is limestone, predominantly limestone. And this limestone is essentially, I think this particular lime, okay, we are going to produce through the limestone, and this limestone is not available as, I think naturally it is not available as limestone in nature. It will be available as calcium carbonate. Okay, this limestone is available as calcium carbonate in nature. Okay, and this calcium being is the predominant metal on the earth. So hence we can obtain the natural, that is limestone predominantly. Okay, that is calcium carbonate. And the next, this calcium carbonate is mildly soluble in water, and sometimes this calcium carbonate can be leached out of water. Okay, and ultimately it will be deposited as an impurity in terms of clay or in the form of kankar. So usually, okay, when there is what I can say, the pure limestone we are not going to obtain, or we cannot use it as a limestone, and whatever the calcium carbonate that is available, so that will be soluble in water, and those soluble material will be deposited as an impurity, as a clay, in the form of kankar limestone. Okay, kankar, that is called kankar limestone. Okay, and one more limestone that is available in the, especially in the coastal areas, that is called shell lime. S-H-E-L-L, shell lime. Next is how to prepare the lime, or what is the manufacturing process of lime. Okay, so we came to know that the limestone is, our lime is available as calcium carbonate in nature, so that will be called as limestone, is CaCO3. So how to manufacture this lime? Okay, so this lime will be manufactured, I can see in the next slide, this manufacturing process of lime. Okay, we are going to do the three distinct operations in the manufacturing process. Number one, the collection of limestone, okay, that is calcium carbonate, and calcination of limestone, that is heating to a particular temperature, and then slaking, that means, okay, we are going to add a water to the burnt lime, that is what slaking process. So one is collection, next calcination, that is heating, okay, to the required temperature, and after heating we are going to slaking, that means add water to reduce the temperature, it is called slaking. Okay, let me do one by one. Collection of limestone. The limestone of required quality are collected at the site of the work. The percentage of impurity in the limestone should not exceed 5%. Okay, so whatever the limestone that is available, okay, we need to collect it in order to produce lime. Next, calcination. Okay, that is burning of limestone is carried out in one of the following ways. It may be through the clamps, it may be through the intermittent kilns or continuous kilns. Intermittent and continuous kilns are, I can say, a completely mechanized operations, okay, and we can control the temperature over here while doing the burning process. But clamp is a conventional method of burning the limestone, conventional method of burning the limestone. Okay, you can see from the photo or the next slide that how exactly the clamp, okay, is done. That means that is the burning process, or I can say the preparation process is done. Okay, you can see that this is commonly, these clamps are commonly observed in the villages. Okay, I can see that completely that whatever the trapezoidal shape, you can see both the plan and also the elevation has been showcased. You can see that the plan and elevation, okay, and usually it will be circular, in front elevation it looks trapezium, okay, and it is completely of brick with a mud mortar, okay, they are going to build it with a mud mortar, and inside this, okay, this will act something like a furnace. This is commonly observed in villages, okay, it is a simple mechanized process. In the bottommost portion, okay, will be having a, okay, the cavity where you are going to put inside some fossil fuels such as coal and all to burn it in order to produce the lime. Okay, so now in this furnace, what I am going to do, I am going to stock the lime inside that, okay, and on the bottom I am going to keep the fossil fuels, preferably coal and all, okay, and I am going to ignite the fire, maybe wood or whatever at the bottom, and I will allow the limestone to burn, okay, to a particular days. That means, as I mentioned, in intermittent kiln and continuous kiln, okay, there will be control over the temperature, but in this case there will be no control over the temperature. In order to get a good quality lime, what I am going to do here is, I am going to do the burning process for number of days, maybe 2 days, 1 day, something like this, that based upon the limestone, okay, the content. Okay, by this, okay, clamps, I am going to burn the limestone in order to produce the lime. Is it clear? So likewise, after burning this, as I mentioned, the next process is slaking. Okay, in the slaking process, okay, whatever the lime which is obtained, that means the limestone will be burned, the limestone which was burned will be obtained as quick lime, okay, that is CaO. Okay, is it clear? That means, okay, during the burning process, that is CaCO3, that was the limestone or calcium carbonate, okay, which I am going to burn inside the clamp. After burning this, the carbon dioxide will be emitted to the atmosphere, as I mentioned in the last session. Okay, by burning the limestone or lime, okay, the carbon dioxide will be emitted to the atmosphere. Likewise, here also, once if I burn calcium carbonate, okay, the carbon dioxide will be emitted to the atmosphere by leaving only CaO, which is called quick lime. Next, which is obtained, okay, that is CaCO3 will be obtained as CaO in after the burning process. Next, that is what the quick lime, that is CaO, which is obtained by burning when exposed to the atmosphere. This is known as natural slaking or air slaking. That means whatever the CaO that will be obtained, if I allow that to cool by exposing to the atmosphere, it will start absorbing the moisture and it will, okay, get cooled. So this is called natural slaking, okay, and the product is quick lime, and it is a very slow process, okay. Hence, what we are going to do is, we are going to add a water to this quick lime so that I can reduce the temperature and I can use it. Okay. So usually following are the two methods as I mentioned. One is slaking to the paste, that means we can form a paste or we can form to the powder form. Okay. So slaking means adding water into the burnt calcium oxide, that is quick lime. Now CaCO3 which I was burnt to form CaO, that CaO will be combined with water, okay, to form calcium hydroxide. Calcium hydroxide, that is CaOH2. Okay, after adding water, okay, it will be available as CaOH2. So this CaOH2 is called lime. Is it clear? So this is what the manufacturing process of lime. Okay, so that means CaCO3, okay, then CaO, then Ca, okay, OH2. So this is what the process. Is it clear? So this is what the manufacturing process of lime. So after knowing about the manufacturing process of lime, now let me move on to the next material, that is pozzolana, because lime pozzolana is a mixture of lime and pozzolana. We came to know how exactly the lime is manufactured. Now we will move on to the pozzolana. So as I mentioned regarding the pozzolana while discussing stabilized mud block, now we are going in detail regarding the pozzolana. So as I mentioned, the pozzolana is a material, we can see from the definition in the slide. Pozzolana is a material which consists of essentially amorphous silica. Okay, amorphous means non-crystalline silica, or a mixture of amorphous silica and alumina, non-crystalline silica and alumina. This is the chemical composition. And this pozzolana is not a cementitious material by itself. So I think I've been mentioned this in the SMB. That means when I'm going to mix a water with the pozzolana, it will not form a paste. Okay, why? Because it will not act as a cementitious content. Why? Because it doesn't have any calcium oxide. It comprises of only alumina silica. Okay, and this will combine in the presence of moisture to form pozzolana. That means if I want to make a pozzolana to be active, okay, then I need to mix this pozzolana, okay, with calcium hydroxide, okay, with calcium hydroxide in order to make it active in presence of water. Otherwise, this pozzolana is not at all active. Even though if you mix pozzolana and lime, it is not at all active. Pozzolana plus lime plus water. So this will make a pozzolana active product. That means it will demand water so that the pozzolana can be reactive and it can perform better. Okay. So now, what are the various pozzolana that are available, okay, so that we can go ahead with a pozzolanic material? The various pozzolanic material available are, you can see that from the slide, powdered burnt clay. I think in yesterday class I have been discussed this. Okay, that is last session, burnt clay, okay, bricks. So burnt clay bricks, okay, we are going to prepare, I think I have been told. Whatever the clay bricks that is overburnt, so those overburnt clay bricks, okay, will be powdered to form powdered burnt clay, and usually this material is commonly called as surki. Okay, it is called surki. Okay, powdered burnt clay, it is commonly known as surki. Is it clear? Okay, so especially this powdered burnt clay they are going to use, it is a waste product when the brick will be overburned, okay, which is not at all useful in the production of, okay, bricks or with the using of wall construction material. Those bricks will be powdered, okay, to form as a powdered burnt clay material, and this material can be used as a pozzolanic material, and this material was predominantly used in olden days. Okay, and this powdered burnt clay is called as surki. Next, fly ash. Okay, I think I have been mentioned this. Fly ash is a material that we are going to obtain after burning the coal for the production of power. By burning the coal for the production of power to a temperature of 1000 to 1500 degree, we are going to obtain a product called fly ash. Okay, and this, whatever the residue that will be left after burning, those material will start flying upwards. Okay, so So that whatever the material that will start flying, because that is having a lesser weight or specific gravity, okay, because of that it is going to fly upwards. So those material will be collected. Those material will be collected, okay, in the electrostatic precipitator. Okay, this is a device I am going to use in the industry to collect those ash, that is called fly ash. So this fly ash is a predominantly used pozzolanic material, okay, that can be used as a best replacing material, okay, to the cement also. Okay, so that is what I am going to mix this fly ash, which is a pozzolanic material, to the cement. Then it is called Portland pozzolana cement. There I can reduce the carbon dioxide emission. It is a completely eco-friendly, I can say, the green product or green cement. Okay, the next material is rice husk ash. Here also this rice husk ash will be obtained by, okay, the next is, you know that the rice mill industries, okay, that having a rice, okay, and that rice, whatever the thing, will be covered by an husk. Okay, those husks, okay, they are going to remove it, okay, in the rice mills, okay, to produce this rice. Those husk is a waste material. Those husk is a waste material. Okay, those husk that can be used, they will be using those husk as a fossil fuel, as a burning material in the industry, okay, in order to generate or run the industry or to generate the power. After burning this husk, okay, which is rice husk, okay, the product which is be obtained is called rice husk ash. Is it clear? Okay, so this is what rice husk ash. This is also a pozzolanic material which I am going to use it, okay, as a best replacing material. But in this, the predominantly used pozzolanic material is fly ash. In the market, whatever the cement you people are obtaining, that is PPC, Portland pozzolana cement. In this, the predominant pozzolanic material is fly ash. Is it clear? Apart from this, as I mentioned in the last session, that is ground granulated blast furnace slag, okay, which will be obtained from the iron ore industry, that is in the Jindal. So that is also one of the pozzolanic material that will be used. I think the best quoted I can say is, okay, whatever the construction practice that is happening in the Bangalore, which is the capital city of Karnataka, that is metro rail and all those things. So this pile foundation, all those things that is happening. So they are pouring the concrete, they are preparing the concrete with respect to the slag. So almost they are replacing up to 40 to 50% GGBS. So this is the thing, they can go with the green. That means the 50% of emission from the cement, they have been stopped, and they have, that place they have been replaced it by a ground granulated blast furnace slag. So this is one more pozzolanic material. And this word pozzolana actually came from the word, okay, the place called Italy, the name Pozzoli. So the Pozzoli is a village, okay, where this name came into the existence. And this, why they are called the material pozzolana, unknowingly they started to use this ash. The very first pozzolana they have been used is volcanic ash. Okay, during the volcanic eruption, okay, after volcanic eruption, this ash will be cooled down after certain number of days. Those ash unknowingly they started to use, okay, with the cement. There it formed a very good pozzolanic material. Is it clear? So that's why I highlighted this pozzolana will be active only with respect to lime and water. Otherwise it is a dead material. Okay, it doesn't contribute anything with respect to the construction. So in order to make it active, this pozzolana need to be mixed with lime in presence of moisture or water. Okay, I can prepare this pozzolanic material. Is it clear? So this is regarding the pozzolanic material. So with this, we will move on to the manufacturing process of LPC, that is lime pozzolana cement. We came to know how to produce lime, we came to know how to produce the pozzolana or what is pozzolana. Now we will move on to the preparation of LPC, that is lime pozzolana cement. So let me go ahead. This LPC predominantly, so many research have been done in IISc Bangalore, Indian Institute of Science Bangalore. They come up with the two techniques of preparing the LPC. One is dry blending technique and another one is wet blending technique. As the name itself indicates, okay, dry blending, that means blending the lime and pozzolana and packing it without any water. That means it is a dry state. Wet blending means blending lime, pozzolana in a slurry form. That means adding water. That is called wet blending. So let me go in detail. So the dry blending means the slaked lime, that is CaOH2, that means after burning, okay, and all cooling and all slaking, okay, that is called slaked lime. And pozzolana should be separated, okay, processed as a dry powder. That means lime powder, pozzolanic powder need to be considered, okay. Those pozzolana may be dried and ground to a fineness of 90 micron. Why 90 micron? Okay, micron means 10 to the power of minus 6. Okay, why 90 micron? Because this, whatever the cement we come across, the size of those cement particles are 90 micron or less than 90 micron. To that particular sizes, we need to ground this pozzolanic material. Okay, next, these lime powder and the pozzolanic powder which was separated need to be mixed. Okay, that is the two powder may now have to be blend. The blending is very, 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 very important. See, if you blend, okay, with the hand, the performance is different. If you blend through the machine, the performance is different. This is a very interesting character. Okay, why? Because if you're going to blend through the hand, okay, that means you are not going to get a, maybe you get a performance or you may not get a good performance. So that's why for a blending of lime and pozzolana, what we are going to do here is we are going to use a ball mill. A ball mill is a device or a machine, okay, it is a huge steel, okay, like a drum, steel drum. Inside that, okay, we are going to put a steel balls of various sizes. Steel balls of various sizes we are going to put inside that, and we are going to make the drum to revolve. We are going to make the drum to revolve, okay, or rotate. That rotation will create a blending of these dry powders, that is lime and pozzolana, in a ball mill. So this ball mill will give a very good blending so that this lime and pozzolana will get integrated in a better way. Okay. Next, okay, and after mixing this, the very important thing is storing. Okay, we need to store these mixed, okay, lime and pozzolana in a LDPE bag, that is low density polyethylene bags. Why? Because the lime have a tendency to absorb moisture from the atmosphere. In order to overcome this, okay, we need to store this lime and pozzolana properly inside the LDPE bags properly. We need to be very careful. Okay, we need to properly store this lime and pozzolana mixture inside the LDPE bags. Okay, so that I can increase the life of a, okay, lime and pozzolana. Okay. Next, the residual moisture, okay, next slide, that is the residual moisture present in the lime or pozzolana will initiate reaction, okay, and that's what I've been told, okay, whatever the lime and pozzolana I'm going to store inside the LDPE bags, I've been told that the lime, okay, if you store for a longer time, the lime has a tendency to absorb the moisture from the atmosphere. It may start reacting so that the lime and pozzolana will be combined or react, okay, to form a hardened product. So we need to be very careful while preserving it. Okay, so that's why, okay, we need to store it properly, and I think I've been quoted over there. If you store the lime and pozzolana mixture more than 14 days, the strength may reduce of LPC by 14%. If you store more than 14 days, okay, the strength will be reduced by 10%. So that's why storing of material is very important. Even cement also, normal cement also, we need to store the material properly. We need to place it in the dark room, no sunlight, okay, need to come inside the room, okay, it should not be exposed, it should be completely dark, and these cement should not be, okay, placed on the floor, it should be placed on the wood planks, so that it cannot absorb moisture from the floors. Likewise, here also we need to store it properly. So this is how we are going to manufacture and store the what I can say, the LPC cement, that is lime pozzolana cement. Next is wet blending. Okay, there blending it dry. Now I am going to blend it wet. That is, the pozzolana has to be produced, need to be ground to 90 micron, same thing. And next will be stored in a LDPE bags. Next, the slaked lime and freshly produced baking lime will be placed at the side. Then the slaked lime and well-ground pozzolana may now be mixed in a simple drum. Okay, and along with that, I am going to add a water. That means lime pozzolana cement slurry will be formed. Okay, where we can, okay, use it. See, one thing we need to be very, okay, observe here is, when you want to use, okay, instantly, that means if you are going to use it now itself, then we can go with a wet blending technique. If you go in to use this LPC cement after so many number of days, then we can go with the dry blending. That means if you're going to do with the site practices, that means if you're going to use the site, immediately we need to mix that and we need to use that. Okay, we cannot store the lime pozzolana water mixture. Okay, if you want to store the LPC, then we can go with the dry blending technique. So this is a best alternative material I can say that can be used, or an alternative building material or construction material I can use to the conventional cement that we are using day-to-day life. We can go ahead. Okay, but the thing is, we need to be very cautious with respect to the performance. So we need to look into the performances. So whether it will perform in a better way or not. That means we need to do the so many properties tests, that is strength, durability, all those things. That means it should be durable. That means it should sustain for a longer time. All those studies we need to do. Okay, next is coming to the gypsum board. Okay, it is the next material that will be predominantly used in the buildings. I can say this is the interior, okay, material. Okay, this is not an exterior material used in building. Okay, in order to make the interior of a building look aesthetically good, okay, we are going to use this material that is called gypsum board. So let me go ahead with this gypsum board. So gypsum board is one of the widely used construction material, mainly in interior design. Okay, instead of using, okay, other materials, the gypsum board we can use it predominantly. I will tell you the advantages why we need to use in the interior. Okay, it is a very good sound absorbing, thermal insulating, lightweight, all those things. So that's why the gypsum board is, okay, more preferred rather than other materials. Next, what exactly the gypsum board is? This gypsum board consists of a core of gypsum. That means it is typically a gypsum, okay, surfaced with, that means the gypsum is surfaced with specifically manufactured paper firmly bonded to the core. That means in the interior core is gypsum. To that, the paper will be impregnated on the outer shell of the gypsum. So that is what the gypsum board. The core will be gypsum, okay, on two sides, okay, it will be having a paper which is firmly impregnated to the gypsum. So that is called gypsum boards. Is it clear? Next, the basis of all gypsum boards products is gypsum. That means whatever the gypsum board we are using is, the majorly is gypsum, okay. So that is the, okay, the board, the majorly it is made up of gypsum. But the surface can be wrapped by various material, that's what I have been told. Maybe paper or maybe fiberglass, anything. Okay, you can wrap it or we can impregnate it. Is it clear? So that's what I have been told. And the very important thing, one must look into this gypsum material. This gypsum is also used in the manufacturing of cement. See, this gypsum has one interesting character. This gypsum, if it is there in the prescribed limit, the setting process is going to happen, okay, neatly. If this gypsum, okay, is there beyond prescribed limit, it will act as a flash setting. That means immediate setting may happen. Okay, no, okay, that means if you want to get a quick setting, we can go with a more percentage of gypsum. Okay, so that's why in the manufacturing of cement, we have been limit the gypsum to the lesser than 5%. We should not go beyond more than 5%. So, okay, we need to be very cautious while using gypsum. Okay, next, this gypsum wall board, or can say dry wall. Okay, dry wall or plaster board, okay, is a plaster board with a wall finish that is available in the varieties of sizes 4 feet wide by 8 feet high. So this is the size we can get it, okay, 4 feet wide and 8 feet height. So this is the size of a gypsum board we can get. Next, what are the properties of gypsum board? It is a very good, next, that is, you can see that, point number 1, that is fire resistant material. So when you are going to use in interior material, especially the people used to call interior fall ceiling. It is a very good fall ceiling material. So on the roof, in order to look aesthetically look good inside the building, we are going to use this gypsum board as a fall ceiling material. Okay, that gives a very good look inside or interior of the building. And by using this, the advantages are, it is a very good fire resistant. You need not to worry about the fire. Okay, it will take care of the fire very good. Okay, no threat of fire. It will prevent the spread of fire very good. Next, why it will prevent the fire better? Because the chemically bound water will be present inside the gypsum. Okay, the chemically bound, okay, the chemical formula that is in the gypsum, that is the water, it comprises of water. That chemically bound water inside the gypsum, okay, which is the boon to the gypsum, okay, which will prevent the fire, or we can say the fire resistant material. Next, the thermal property, the second point, the thermal properties of the gypsum. The gypsum can regulate the variables such as humidity and temperature. Okay, that's why we prefer gypsum board. So this gypsum board, by using this, we can reduce the temperature inside the building. For example, if the roof of your building is exposed to the atmosphere condition, we can reduce the temperature inside the building. We can feel cool inside the building by doing the fall ceiling or by doing the interior work with gypsum board. So this is the very good advantage of gypsum boards. Next, coming to the acoustic property of gypsum, that is the another thing, that is thermal insulating property. So it is a very good sound absorbing material. Okay, it will not allow the sound to travel through the walls. It will act like a noise barrier. So that's why in the majority of the malls or the theaters, they prefer this gypsum board. It is a very good acoustic material. I can go with this gypsum boards. It is a very good noise barrier. So that's what I've been idea. It is a commonly used as a thicker thickness and no less demanding than gypsum. So gypsum is designed for absorbing sound and reducing reverberation. So it can reduce the sound. That's why in the the theaters, cinema malls or the theaters, okay, we can come across these gypsum boards. Next, non-combustible property. Okay, it is a very interesting property. Why? Because as I stated, it is chemically contains water crystals. So because of this water crystal presence, it is a non-combustible material. We can see that. Okay, the calcination is a process of dehydrating gypsum with heat. Calcination, I told that it is heating. Okay, creating a protective layer over the components, preventing them from combusting and allowing the materials around them to retain the lower or reducing the temperature. So this is what the another interesting property or advantages of a gypsum board. Next is, you can see the different types of gypsum boards. Okay, one is based upon the use, we can go ahead. If you want very good fire resistant material, we can go with the fire resistant gypsum board. If you want more water resistant material, we can go with the water resistant gypsum board. If you want backing gypsum board, that means back of the wall will be using a gypsum, then we can go with the backing gypsum board. Dry wall gypsum. These are the different types of gypsum boards that are available in the market. Okay. So next, we'll move on to the advantages. Okay. The advantages are, this gypsum are also used in plaster to provide smooth, okay, the crack-free surface, and gypsum boards gives a smooth, continuous surface to which you can apply paint directly. Okay, no need to worry because of the smooth surface. It is the one advantage. The second advantage is gypsum has the property of balancing the, okay, the building indoor temperature and humidity. That's what have been highlighted. So you can reduce the temperature, okay, and humidity. You cannot feel humidity inside the building. And especially where the, I can say the season or condition is hot and humid condition is there, there we can go with these gypsum boards. Next, the use of gypsum good with budget boost with creativity of architect. That means based upon the architects, we can reduce the cost also. That is depend upon the architects. The gypsum products are simple to install and do not necessitate the use of trained staff. It is very simple. It is just a panels or a board. Okay, you can see it. Okay, it is simple to install. No need to bother about the, okay, the labors and all. It is a, okay, demands, okay, I can say the unskilled labors or less amount of skilled labors. So this is regarding the gypsum board which I wanted to discuss. Okay, with this I am going to end this session. Okay, I think in this session we have been discussed the two components, or I can say the two building materials that will be used. Okay, one thing I have been discussed is predominantly, that is gypsum boards, and another one is LPC. Okay, LPC is an alternative to the cement. And another one is gypsum board is one of the interior roofing material that can be used. And I can say walling materials also. But in the residential buildings and all, they will not be used that much. Residential building, they can use it only for a roofing material, not as a walling material. But in the cinema malls or the theaters, they can use it for both roofing and walling because they need to absorb the sound. That's why they can prefer both in the vertical way and also in the horizontal way. Okay, they can go ahead. So that's what I wanted to discuss in this particular session regarding the manufacturing of LPC and the gypsum board. Hope the concept has been clear. Okay, thank you for listening this session. We will discuss some more building materials in the next session. Thank you.